We are Group 12 in Professor Bronco's Aerospace 2201 Aerospace Fundamentals class. Our project vehicle was the Starship. My name is Sophia Cherry.
My name is Brooks Van Esselston.
I am Alessandra Later.
I'm Ryan Fox.
And I'm Emma Elistad.
Starship, developed by SpaceX, is a groundbreaking spacecraft designed to carry both crew and cargo to destinations such as Earth orbit, the Moon, and Mars, serving as a cornerstone for future space exploration. Equipped with the human landing system for crewed takeoff and landing on the Moon, its stainless steel design, finalized in 2019, includes a large payload to support lunar and Martian colonizing efforts. The reusable Super Heavy booster enables controlled landings at SpaceX launch sites powered by Raptor engines with twice the thrust of the Falcon 9 Merlin engines. Starship's fully reusable design aims to reduce costs and environmental impact, setting a new standard for sustainability. The journey began in 2012 with the Mars Colonial Transporter concept, evolving into the interplanetary transport system in 2016, and later multiple Starship variants announced in 2017. Milestones include the successful 2019 Starhopper flight, the 2021 SN-15's prototype first full takeoff and landing, Starship 24's 2023 full flight test on a Super Heavy booster, and Starship 25's successful passage of the Kármán line later that year. By 2024, Starship had achieved several launches and introduced 2 new versions, solidifying its role as a revolutionary tool for humanity's expansion to the Moon, Mars, and beyond.
Starship's development journey began in 2012 with the Mars Colonial Transporter, a bold concept aimed at Mars colonization. By 2016, this evolved into the Interplanetary Transport System, designed as a fully reusable spacecraft capable of carrying over 100 metric tons to low Earth orbit. This marked a significant step towards SpaceX's vision for interplanetary exploration. Between 2017 and 2018, SpaceX transitioned from carbon composites to stainless steel, prioritizing thermal protection and cost efficiency. This material innovation played a key role in enabling robust atmospheric re-entry. Testing commenced in 2019 with the Starhopper prototype, which successfully validated the Raptor's engine's performance and structural integrity. Following this, the SN series of prototypes underwent rigorous testing, culminating in the SN-15's prototype's historic achievement in 2021, becoming the first full-size Starship prototype to perform a high-altitude flight and land successfully. Meanwhile, the Super Heavy booster was developed to complement Starship, standing at 70 meters tall and equipped with 33 Raptor engines. This booster uses advanced grid fins and thruster vector control for precise landings, with the ultimate goal of making the entire Starship system fully reusable and dramatically reducing launch costs. As shown in the cost efficiency graph, Starship stands out as the most cost-effective option for reaching low Earth orbit, with a target of $100 per kilogram. This is achieved through a full reusability of both Starship and the Super Heavy booster, allowing for rapid turnaround and minimal refurbishment between flights. By leveraging in-house engine production, cost-efficient stainless steel, and its ability to be caught by the launch tower instead of using landing legs, SpaceX has drastically lowered operational expenses, making Starship a revolutionary step in affordable space access.
Starship refers to the second stage of the Starship system and the overall system, but Starship, when only referred to as the second stage, is 50 meters tall and the Super Heavy booster is 71 meters tall, meaning that fully stacked, the Starship system is 121 meters. The diameter of Starship is 9 meters and the payload capacity is between 100 to 150 tons in its recoverable configuration and 200 tons in its expendable configuration. The Super Heavy booster is equipped with 33 Raptor V2 engines, each which produce 230 tons of thrust. Starship uses a hot staging ring which allows the ship to begin firing while still connected to the Super Heavy booster in order to separate. Starship is equipped with 3 Raptor vacuum engines and 3 Raptor sea level variant engines, which have the ability to gimbal 15 degrees. Raptor is made with SX500 alloy, copper, aluminum, and steel alloys, which SpaceX developed specifically for Raptor and is proprietary to the company. Raptor is the 3rd full-flow staged combustion cycle engine to ever be developed and is the only one currently in operation. Starship uses methane for fuel and liquid oxygen for its oxidizer. The Super Heavy booster uses grid fins and a thrust vector control system to steer itself back to the launch tower. Stage 0, aka Mechazilla, is also an important component of Starship. Mechazilla catches both the Starship and Super Heavy booster, which means that landing legs are not required for landing, which significantly reduces the weight of each vehicle. Starship uses about 18,000 heat shield tiles, which are placed on the bottom side of the ship, which experiences the most heat during re-entry. The tiles are silica-based and protect the ship from plasma and heating during re-entry when the ship experiences about 2,600 degrees Fahrenheit.
Block 1 of Starship was retired after Integrated Flight Test 6 on November 19th of this year. Block 2 is planned to be used in the upcoming IFT-7. Meanwhile, Block 3 is still in development and not much is known about it right now. Starship is currently operated and in development by the American aerospace company Space Exploration Technologies Corporation, also known as SpaceX. Starship is planned to be used for space cargo operations such as deploying Starlink satellites, telescopes in orbital refueling, human spaceflight in the Artemis program and other colonization efforts, point-to-point Earth operations including military and civilian transport, and potential rumored Department of Defense operations. Due to the iterative and incremental development system used by SpaceX, there have been many incidents involving Starship. A total of 11 Starships have been destroyed so far during testing. The following incidents occurred only during full integrated flight tests of Starship. During the first integrated flight test, the launch pad was destroyed on liftoff of the rocket due to a lack of a water deluge system or flame trenches. 3 Raptor engines failed to light on startup, and control was lost after passing max Q. Due to this, the AFTS was activated and the vehicle was destroyed. During the second IFT, the Starship booster was destroyed after multiple engine failures during its boost backburn, and the second stage was destroyed by the AFTS after a fire started during liquid oxygen venting. During IFT-3, the booster was lost at 462 meters after multiple engine failures. The second stage lost control and exploded during re-entry due to uneven heating. During IFT-5, minor damage to the control flaps was spotted on video during re-entry. The ship exploded shortly after hitting the water, but this was intentional. During IFT-6, the communications antenna on the launch tower was destroyed. Due to this, the ship was sent a command to divert and land offshore.
Next up is the retirement and the next generation of the Starship. So Starship V1 was retired on November 19th, 2024, which in the context of this project is called Monday. So in this project, the Starship V1, your main changes from V1 to V2 is bigger, larger rocket capable of taking more cargo further. So it's an extended one ring relative to V1, making it larger, a higher thrust output, as well as more propellant, almost a 1/4 increase, and then improved T-shield configuration and flaps, and then orbital refueling capabilities for, in the future, more extended long-range flight. Starship V3, which is going to be after the V2, is in the design stage right now, and that is almost 20 meters taller, as you can see at the image on the slide, than both V1 and the V2 with a 10-meter taller booster. It has twice as many ship VAC engines as 1 and 2, and then we'll have the capability to transport 200 plus tons into orbit. If we go to Mars, it will be on a V3.
Period.